Around 1 in 6 properties in the UK is at risk of flooding, not only endangering people and property, but also damaging the environment as pollution washes directly into our rivers, seas and out of our overloaded sewers. The problem is not going to go away, with sewer flooding predicted to increase by over 50% by 2040. Hydro International's hydro brake flow controls have been successfully used as key components for stormwater and wastewater management since the late 1970s, reducing and preventing the risk of flooding. Over that time, we have gained significant experience with vortex flow control design and its application. Hydro International work closely with water companies, local authorities, consultants and developers to design and install thousands of units worldwide, delivering precise flow control solutions in a variety of application areas. Following unparalleled investment in research and development, Hydro International now offer the Hydro Brake Optimum. Whilst similar in appearance to other flow controls and apparently simple in design, its secret lies in the extensive research which allows us to optimize the full performance characteristics, in particular the exact point at which the vortex starts to develop within the device to deliver maximum flexibility to the system designer. In order to see these benefits, we need to understand how the Hydro Brake Optimum operates. Here we can see a typical tank sewer consisting of a Hydro Brake Optimum flow control with a volume of storage in the upstream pipework. Under low flow conditions, we are in the pre-initiation phase. The Hydro Brake Optimum behaves like a traditional orifice with a large opening, and flow is gentle with minimal turbulence inside the Hydro Brake Optimum or the outlet pipe. The end of this phase is called the flush flow point. As the water level increases, a vortex begins to form within the unit. At first, there is not enough energy in the water to sustain a stable vortex. This is called the transition phase. As the water level continues to increase, enough energy is eventually generated to maintain a stable vortex and we reach the kick flow point. We then enter the post-initiation phase, where the center of the outlet is filled with air, which effectively chokes the flow through the unit, restricting it to the design flow. This phase continues until we reach the primary design point. As the water level subsides, the vortex collapses, and the Hydro Brake Optimum returns to operating like a traditional orifice with a large aperture, ensuring that the drainage system is ready for subsequent rainfall events. The manipulation of the flush flow and kick flow relative to the maximum permitted discharge rate and maximum head is of particular relevance to engineers as it can significantly influence the final system design. For optimum hydraulic performance, the flush flow point can be matched to the permissible discharge rate from the system, allowing more water to pass through the unit during the earlier stages of a storm. This can reduce upstream storage requirements by up to 15% when compared to other vortex flow control devices, offsetting the cost of the device and significantly reducing overall project costs. The physical dimensions of the Hydro Brake Optimum can be adjusted, which is of particular benefit for retrofit schemes, as it allows units to be designed to fit to existing infrastructure, eliminating costly replacement or regeneration works. The Hydro Brake Optimum is future-proofed against climate change and future development through the optional adjustable inlet, allowing flows to be adjusted by up to 20% post-installation. Returning to our typical tank sewer system, dynamic hydraulic modeling takes account of the full head discharge characteristic curve. Substitution of the specified Hydro Brake Optimum with an alternative flow control with the same design point but different characteristic curve can result in undercapacity within the network. A flow control that doesn't pass forward enough flow reduces the level of protection afforded to the upstream infrastructure and can increase the risk of localized flooding. Similarly, increased pass-forward flows can overload the downstream system and lead to erosion or damage to sensitive areas. The result of any undercapacity in the system is the need for increased storage, which in turn can dramatically increase the costs, making it an expensive alternative to optimum flow management. Maximizing the clearances of a flow control is critical to minimizing the risk of blockage or ragging and helping to reduce the maintenance frequency and cost. Here we see 3 common flow control solutions, all based on the same design point. If we overlay the 3 outlets, we can see that the Hydro Brake Optimum offers the largest clearances of all the solutions. This is the result of our continual research and development program and allows us to offer the most refined and robust flow control product available today. Whether holding back floodwaters in temporary storage reservoirs to protect major population centers, diverting peak flows to maximize treatment and prevent overload or erosion damage to sensitive suds areas, or enabling efficient use of latent capacity within existing sewer infrastructure, Optimum Flow Management is already providing effective protection to thousands of properties worldwide. The Hydro Brake Optimum. There is no equivalent.